have discussed how to calculate oxidation number, right? Rules to find oxidation number. Oxidation number. Right? You guys know all the rules. What were the rules? What were the rules? For like group 1 elements, charge will be +1, and for group 2, +2, and for halogen, -1. And we didn't discuss about the oxygen, right? Oxygen has -2 generally, but it has 3 forms. It has 3 forms. What are that? The first one is normal oxide form. Second one is superoxide. And the third one is your peroxide. Okay. In case of oxide, you have the charge -2. Okay. In superoxide, you have charge -1/2. And in peroxide, 1. What is the linkage, like how to identify whether it is oxide, superoxide and peroxide? So for peroxide it's very easy. It's, you see the oxygen single bond. This linkage we call peroxide linkage. Peroxide linkage. Okay, this we call peroxide linkage. And normally you have in all the questions, just think oxygen as oxide. Okay, these are like special cases. Generally you see oxide. When you need to see this, I'll tell you. Okay, so write one statement. The statement is your oxidation state. Oxidation state cannot be more than valence electron. Okay, oxidation number cannot be more than valence electron. Okay, this is very important point. Write down this. And how to use these things, now we'll learn. This is done, this part. Okay, so let's suppose you have a molecule MnO4-. Okay, you have to find the oxidation state. It's very simple. You have to find the oxidation state of Mn. And in maths, you know, whatever you have to find, that you consider X. X is your favorite, right? X plus, what is the charge of oxygen? -2. Very good. How many oxygens are there? 4. Okay, is equal to, is there any charge in this overall molecule? What is the charge? -1. So write here -1. If there is no charge, then write here 0. Right? If here plus charge, if here +2, then write here 2. Whatever will be the charge here, write down after equal to. Okay, fine. So in the question you had -1, right? So this will be -1. Now this much mathematics you know. What will be the value? X -4 is equal to -1. This will be x -8. So X will be, you will be equal to plus 7, right? This is your oxidation state of manganese. Now if you want to find the oxidation state of, let's suppose K2 Cr2O7, tell me this, what will be the oxidation state for this? You have to find the oxidation state of chromium. Okay, try this one, and try this one, CrO5, and one more is there, H2S2O8. Okay, find the oxidation state of these things. This is done, this part. Okay, you have to find the oxidation state of CrO5. So let's suppose it is X plus oxygen charge minus 2 into 5 is equal to, is there any charge in this molecule? No, so it will be 0, right? X minus 10 equal to 0. X is equal to plus 10. Is it possible to having oxidation state of chromium plus 10? No, because valence electron, the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d, 5. This is your valence shell. Valence electron is, how many valence electron it has? 5 plus 1, 6. But oxidation state is 10. This is not possible. The oxidation state cannot be greater than valence electron. Okay, it means this is wrong. You have to use some other method. In this case, you need to think about this oxygen. Okay, we have discussed 3 types of oxygen: superoxide, peroxide, and normal oxide. It means it is not your normal oxide. You have to make the structure. How to draw the structure, that you don't know. Okay, so chromium pentaoxide has butterfly structure. Okay, you will see the butterfly of chemistry. Chromium this is your butterfly. Okay, looks like butterfly. Yes. Here, how to find the oxidation state? It's very easy. What you can do, this, what linkage is this between oxygen single bond? Peroxide linkage, right? It means these two oxygens are peroxide, right? So it has -1 charge, -1, -1. This is also same, -1 and -1, and this is your normal oxide, -2. So these two oxygens, -2, -2, total -4, and -2, -6. These are for oxygens. So what about the metal? Metal will have just opposite. If it is -1, it will have +1, -1, +1, -1, +1, +1, and from this side +2. Total you are getting +6. Yes. So this is your actual oxidation state of chromium, not this one. Okay. So you have to think about the oxygens, different forms when you have this issue, right? When oxidation state will be greater than your valence electron, then you have to consider the different forms of oxygen. Otherwise normal, as you do. Okay, and you have one important thing. Okay, this is done? No. Okay, write it. Okay, let's suppose you have the bond between A and B, single bond. Okay, and the case is electronegativity of B is more than A. Okay, if you want to break this bond, B is more electronegative, so it will have minus charge and this will have plus charge. Plus 1. Okay, if you have the bond between A and B, double bond, how many bonds you have to break in this case? 2. So you will have minus 2 and this side plus 2. Okay, if you want to break the bond between A and B, and here how many bonds are there? 3. So this will have minus 3, this one plus 3. Okay, this way you can these things you can use for your structure cases, right? Okay, can you draw the structure of this molecule? H2S2O8. This part is done, right? This part is clear? Yes or no? Okay, good. You have H2S2O8. Tell me the oxidation state of sulfur here. Sulfur oxidation state. What is the oxidation state of sulfur here? 7. So you guys are getting plus 7. That is your greater than valence electron, right? So in this case, normal rule is not applicable. So you have to draw the structure. When we need to draw a structure? When? Yes. The condition is this. If the condition will be like this, then you have to draw the structure of the molecule. So draw the structure. It's very simple. You guys know how many bonds hydrogen forms? Single bond. Oxygen, double bond. Sulfur, 6 bonds. Okay, it has capacity of formation of 2 bonds, 4 bonds, 6 bonds, but the maximum capacity is 6 and it is the central atom here. Okay, so this is the general skeleton of sulfur when it is present with oxygen, right? This is the general skeleton. Okay, so you have this general skeleton. Okay, same for phosphorus, you have like this. Okay, now you have how many hydrogens? 2. So put hydrogen with oxygen like this. Okay, how many oxygens done? 6. You have 2 left. So you have only this place, right? Put 2 oxygens. This is your H2S2O8 structure. Now you can easily identify the oxidation number by this method. Do it. Try. Now what you guys are getting? Oxidation state of sulfur plus 6. Very good. So you guys are getting plus 6. How? Single bond. You know, oxygen is more electronegative than sulfur. So this has -1 +1. Very good. Simple. -1 +1. Double bond is there, right? Oxygen is more electronegative, so it has -2 +2 -2 +2. So overall charge +6. Okay. Same for this molecule also, +6. Here the oxidation state of sulfur is +6. Okay. No need to draw the structure in all the time. Only when you have this condition, then only you need to draw the structure. Okay. Now you have questions, sir, how to draw this structure. That's very difficult. You don't know this will be like this. Okay. So you have the option. First of all, you have to understand how many number of bonds an atom form. Okay. If you know the number of capacity, number of bonds capacity, then you can easily form. So I'm giving you one homework to draw this P4O10 and H3PO4 all thrice. Okay, these are two homeworks. You have to draw the structure at home. Okay, don't Google it. This is your homework. And for sulfur molecules, you have this general skeleton, right? This is your general skeleton. And for phosphorus, you have this. Okay, no need to draw all the time structure. You have only 2-3 things that structure you required. Okay, that I'll cover in this class also. Clear? Okay, now tell me the oxidation state of this. Potassium. Okay, these things are done. Try that one. And also try for this OF2 and O3. Okay, try this 3. What you guys are getting for K plus 4? Is it possible? Is it possible for potassium to have +4? No, right? It's not possible because it has the valence electron 1. Now what you can do? Just find the oxidation state of oxygen now. Find oxidation state of oxygen. So you have KO2, right? I'm finding the oxidation state of oxygen. You have potassium +1 plus 2x equal to 0. So 2x is equal to -1. X is equal to -1 by. So oxygen is present in -1/2 oxidation state. What is the case here? Which form of oxygen is here? Superoxide. So this is your superoxide, right? This is your superoxide case. Okay, now try this one, O3. Sorry, it has like O3 minus. Okay, try that one. It's very easy, same as I3 minus, right? What will be the oxidation state here? -4. It's not possible, right? -4 is not possible. So try for the ozone. It's very simple. You have to find the oxidation state of oxygen here. How many oxygens are there? 3x, right, is equal to -1. So x is equal to your -1/3. In ozone form, oxygen present in -1/3 oxidation state. Okay. This one. This one. Try OF2 case. OF2 case. Think. You got the answer? What is the answer? 2. -2 or +2? +2. Yes. So in this case it is present in +2. Okay. So these things you need to remember. These are some special cases. And other than this, you can easily find the oxidation state of all. Okay. Clear? Everything? This is your homework. Okay. Now we'll learn application of oxidation number. Okay, you have application of oxidation number. The first case, the first application is to identify the acidic nature. Basic nature or strength. Okay. How? Simple. Oxidation number is directly proportional to acidic strength. And inversely proportional to your basic strength. Okay. I'm giving you one question. You have HClO, HClO2, HClO3 and HClO4. Find the oxidation state of chlorine first and tell me which one is your more acidic in nature. Okay. Find the oxidation state. Tell me, this one oxidation state is +1. Very good. +1 here, +3, +5, +7. So which one has the highest acidic nature, acidic strength? HClO4, right? Okay. Simple. Acidic nature means acidic strength is good. In this type of question like acidic and basic, simple, understand. For acid, acid is what? Who can release H plus easily. So which molecule can easily release H plus? That is your most acidic. You have positive sign, right? You have +7 already. Do you want plus H? No, you are already rich. You don't want some little things, right? So you don't want H plus, you can say get out. So this already has positive charge and again H plus is also positive. So there will be more repulsion between positive. So H plus will go out easily. Okay. So H plus can be only attracted by negative charges. if you have negative oxidation state, or you have some molecule which decrease your electron density, or sorry, increase your electron density, then only H plus will be there. Otherwise H plus wants to go. So here already it has +7, so H plus don't want to live here, it will go out. Okay, this is the case when you have to find the, like you can easily find the acidic strength by oxidation state. In organic chemistry we'll learn some other groups also. Write down. Yes, it's not coming. +1. Simple. You have hydrogen 1 plus chlorine X and oxygen -2 equal to 0. -2 -1. Fluorine bromine iodine, it's not here, right? +1. Yeah, but you have to find the chlorine, right? In this case you have to find the chlorine, right? In same as in this case, you know oxygen -2, right? But you have to find the oxygen itself. Okay, clear? You have to find that. So this data is not applicable there. Clear this one? Yes. Okay, you have next application. The second one is to know acidic, to know reducing agent and oxidizing agent. Okay, there is two things. If the metal or if the atom present in its highest oxidation state, then it will act as oxidizing agent. Okay, and the second case, atom is in lowest oxidation state, then reducing agent. Okay, you have two statements. When the atom, okay, present in highest oxidation, highest, then it will act as an oxidizing agent. When it is in lowest oxidation state, then reducing agent. You know how to find the highest and lowest oxidation state, right? Okay, I'll tell you, don't worry. Write down this first and tell me the electronic configuration of nitrogen. Z is equal to 7. Electronic configuration 1s2, 2s2, 2p3. First of all, valence electron. How many valence electron? 5. Right. So simple. Valence electron is equal to your highest oxidation state. Highest oxidation state. Okay. For an atom, the valence electron is equal to its highest oxidation state. So it has 5 valence electron, right? 5. So highest oxidation state will be 5. Highest oxidation state will be 5. Clear? So if nitrogen is present in +5 oxidation state, it will act as an oxidizing agent, right? If any atom present in its highest oxidation state, then it will act as oxidizing agent, right? Okay. How to find the lowest one? It has 5 valence electron. How many more required to make it to complete the octet? 3 more, right? You need 3 more to complete the octet. So you need 3, means you are taking loan from someone. That's why negative. And this is your lowest oxidation state. Okay, lowest. Clear? Now you can easily identify, you can easily find the lowest and highest oxidation state. So in lowest oxidation state, nitrogen will act as reducing agent, right? Clear? Write down this. Then clear? It's clear? Okay. Now we'll learn how to balance the oxidation or how to balance the redox reaction. Okay. This is your very important topic, balancing of redox reaction. Redox reaction. There are 2 methods to balance the redox reaction. What are that? The first one is your oxidation number method. Oxidation number method. Okay. And the second one is your electron ion method. Okay. This electron ion method is in 2 medium. Okay. We balance this electron ion method in 2 medium. One is your acidic medium and another is your basic medium. Okay, acidic and basic medium, that we'll discuss next class. I'm just writing the how to balance through oxidation number, the steps. Okay, what are the steps you have to follow? So the first step is your, first of all you have to find the oxidation number, okay, of the central atom or the atom which is oxidized or reduced. Okay, find the oxidation state of central atom. This is your first step. Second step, separate the oxidation reaction and reduction reaction. Okay, separate the oxidation and reduction half reaction. Okay, after that you have to balance the charge. Okay, balance the number of electron. Okay, you have to balance the number of electrons, or you can say charge. Okay, how many gain of electrons or loss of electron, that you have to balance in this step. After that, balance the number of atoms except hydrogen and oxygen. Okay, balance all the atoms except hydrogen and oxygen. Okay, and finally balance your balance oxygen atom by adding H2O on the opposite side. Okay, and the last is balance H atom by adding H plus. Okay, these are the your steps, and at the end you can just add both the reaction. At the end, add the reactions. Add the reactions, your half reactions. Okay, these are the steps you have to follow. Okay, write down this. This method will learn tomorrow. Okay, write down the methods first. So you have one example. The reaction is MnO4 minus plus Fe plus 2, and it is going this forming Mn plus 2 and Fe plus 3. Okay, this is your reaction. You have to balance this. First of all, you have to find the oxidation state. Find the oxidation state of Mn. What will be the oxidation state here? Plus 7. Okay, and all other atoms oxidation number is already given. Now identify whether the where oxidation happened and where reduction happened. Plus 7 to plus 2. What is this? Reduction. Very good. Reduction. Plus 2 to plus 3. Oxidation. Right? Okay. Fine. Next step, the first step is done, right? You have to separate the oxidation and reduction half cells. So where oxidation happened? Fe plus 2 to Fe plus 3, right? Let's suppose this is your equation 1. And reduction happened where? MnO4 minus plus 7 to Mn plus 2. This is your equation 2. So second step is already done. Balance the number of charge. right? Here the charge change in +2 +3. So you have to add one more electron on this side, right? Yes, because you have 3 positive charge. You are adding one electron. That electron will neutralize the positive charge. You will get 2. Here also +2. This side also +2. Here you have +7 +2. You have to add 5 electrons. Clear? Right? Now see, the electrons are not balanced in both the equations. Here 5, here 1. So in this case, just multiply the number of electrons. How many number of electron here? 1, right? So multiply with 1. Here how many number of electrons? 5. Multiply by 5. Okay? What you will get here? 5 Fe plus 2 and 5 Fe plus 3 plus 5 electron, right? And in this case 5 electron plus same Mn plus 2. Okay, so your this step is already done. You have to balance now number of atoms except hydrogen and oxygen. So you have to balance the iron atom. It is already balanced, right? 5 Fe 5 Fe, 1 Mn 1 Mn. So this step is not required here. You have to balance the atoms except hydrogen and oxygen. So it's already balanced, right? See, Fe is already balanced, Mn is already balanced. Now you have to balance the oxygen atom. How? By adding H2O on the opposite side. So you have oxygen in this reaction, right? You have to add water on the opposite side. How many oxygen you require? 4. So 4 molecules of water you need to write. Okay, clear? Oxygen is balanced. Now you have to balance hydrogen. How to balance hydrogen? Balance the hydrogen atom by adding H+. So you have how many hydrogen here? 8, right? 4 is to 2, 8. You have to write 8 H+ on this side. Your reaction is completely balanced. Now you have to only add the reaction. Just add this reaction. Okay, I'll erase this part. Okay, now just add these two reactions. If you will add these two, 5 electron and 5 electron will be cancel out. What you are getting? 5 Fe plus 2 plus MnO4 minus plus 8 H plus and Mn plus 2 plus 5 Fe plus 3 plus 4 H2O, right? Yes? Okay, is this clear? How to balance? All the other two methods are also same. Okay, only the first step, here we balance the electron. The Balancing of electron will be at the last. Okay, clear? You will get the questions like sometimes you will have the balanced chemical equation. Okay, you just need to tell the coefficients. Write this. Okay, this coefficient. Like let's suppose x, y, z. It is given. It is x. This is y, and this is z. You have to identify. So for that question, you first need to balance the reaction. After that, you will get the coefficient. And sometimes they can ask in numerical answer type question, what will be the value of x plus y plus z? On that time, you have to add all the coefficient. 5 plus 8 plus 5. Okay. Is this clear? Okay. 5 electron, how? You have plus 7, right? Here you have plus 5. So if you add 5 electron, you will get plus 2. Electron means what? Minus, right? And you have plus 7. So you will get here plus 2. Same. This side you have plus 2. Yes, you have to balance. वो बताएंगे ना, वो इसका भी कंसिडर कर सकते। मैं जस्ट एग्जांपल दे रहा था, मैं बस बता रहा था कैसे आ सकते हैं क्वेश्चन। सबका आएगा, वो बता देंगे कि किसका करना है। वो जस्ट आई वाज गिविंग एग्जांपल। इट्स क्लियर, राइट? ओके, डू यू वांट वन क्वेश्चन? Okay, try one question I'm giving you. Try this. Okay, balance this. First of all, you have to find the oxidation state. Oxidation state of chromium here plus 6. Okay, here oxidation state of carbon. Tell me. Find it. 2x minus 8 equal to minus 2. So x is equal to 6 by 2 plus 3, right? Plus 3. X is equal to plus 3. What's here already given? And here oxidation state of carbon plus 4. Okay, is this clear? You know, right, how to find the oxidation state. It's the basic thing. If you don't know this, then you cannot balance the reaction. Okay, and to find the oxidation state, you will see in coordination chemistry also, class 12. So it's very important. If someone has doubt how to find the oxidation state, ask me, I'll help you. Okay, this is very important. If you don't know this, then you cannot solve any question. Okay. Next, what you need to do? Separate the reaction. What is the next process? Tell me. Tell me loudly. You have to write. Okay, so what is happening here? Reduction, right? Reduction. And here, what happened here? Oxidation. Next, you need to separate the reaction, right? So Cr2O7 having plus 6 is going Cr plus 3. Let's suppose this is your equation 1. And another one is C2O4 2 minus plus 3 is going CO2. Equation 2. Okay. What you need to do here? What? You have to balance the charge. What you need to do here? Balance the charge. Here you have plus 6. Here you have plus 3. So you have to add 3 electrons, right? Plus 3. And here plus 4. You have to add 1 electron this side. Right? Now you need to balance the number of electrons. Do nothing. This number of electron multiply with this. This many number of electrons just multiply with the coefficient. Okay? No need to think. Whatever the number of electron here, just multiply with this. Okay? Whatever the number of electron in this case, multiply with the above reaction. What will you get now? So 3 electron. Okay, leave it. Yeah, 3 electron plus Cr2O7. This is your second step. Okay. Step 2. O7 plus 6 minus, you are getting Cr plus 3. Same to same. Here 3C2O4 2 minus plus 3 3CO4 plus 3 electrons, right? This is your after multiplying the reaction. So now charge is balanced. Next step is balance the number of atoms except hydrogen and oxygen. How many chromium here? 2, right? You have to multiply with 2. Clear? How many carbon here? 3 to the 6. Here 3. Right? So you have to multiply by 2. You have to make this 3 to the 6. So you have to multiply here 6. Clear? Number of atoms except hydrogen and oxygen is balanced. Next step, balance the oxygen atom by adding what? What? H2O, right? How many oxygens here? In the first reaction, how many oxygen? 7. You have to add 7 H2O. Okay. Next, here how many oxygens are there? 3 4 the 12. So here oxygen is already balanced. You can see 6 to the 12. Oxygen is already balanced. Now you have to balance the number of hydrogen. How many hydrogens here? 14. You have to add 14 H plus. Done? Right. Now just add the reaction. So 3 electron will be cancelled out and add the reaction. So you will get here 14 H plus Cr2O7 minus plus 3 C2O4 2 minus 2 Cr plus 3 plus 6 CO2 plus 7 H2O. This is your balanced chemical reaction. Okay. Any doubt here? This is very important. If someone has doubt, ask me. You will get 2-3 questions from here. The balancing, and you can balance by any method, like your basic medium, acidic medium, or oxidation number method. Okay, it's up to you. You will get same answer. Only in basic medium you will get, in all medium you will get the same answer. The process will be different. I feel this method is very easy. Okay, and basic medium is bit complicated. You will see. Clear? You have doubt? 14H plus. How many here? 7 into 2. 14H. So you need 14H. Okay. Clear? Done? Okay. So next class we'll see the two methods in basic medium and acidic medium, electron ion method. Okay. Thank you, class.